Hello everybody and welcome to the channel. In today's little lesson we are going to be doing some beginner trigonometry. Specifically we're going to be doing right triangle trigonometry. So right triangle trigonometry is where we have, well, a right triangle. And we want to find the missing components of our right triangle using our trigonometric functions. So one of the first words you should hear whenever you're studying trigonometry is the word SOHCAHTOA. And SOHCAHTOA is a mnemonic to help you remember how to solve for the missing components of your right triangle. The S, the C, and the T they stand for the trigonometric functions. They stand for sine, cosine, and tangent. And now you may be asking, okay, what does the rest of the word stand for? What's the OH, the AH, and the OA? Well, whenever you're using SOHCAHTOA, you look at your triangle from a given angle. We'll call it theta. The side across from theta is your opposite side. The side next to theta is your adjacent side, and the side opposite your right angle is your hypotenuse. So sine of theta is going to equal our opposite side over our hypotenuse. The cosine of theta is going to equal our adjacent side over our hypotenuse. And our tangent of theta is going to equal our opposite side over our adjacent side. All right, so now let's apply this to a problem. Let's scroll down a little bit, create a nice right triangle. Okay, so we have a right triangle. And we have some angle theta. And I want to know what the sine of theta is. Well, let's name all of them. I want to know the sine, cosine, and tangent of theta. So we need to remember, what do we need to remember? Of course, we need to remember SOHCAHTOA to help us solve this problem. So the sine of theta is going to be the opposite over our hypotenuse. So sine of theta is going to be equal to 4 over 5. Cosine theta is going to be our adjacent side, 3 over our hypotenuse. So cosine of theta is equal to 3/5. And the tangent of theta is again the opposite side over our adjacent side. So this will be 4/3. Okay. Now this is sine of theta, cosine theta, and tangent of theta. What if we included the other angle? Let's call it beta. We have angle theta and angle beta. Okay? And I want to know the sine, cosine, and tangent of angle beta. Well, the sine of beta is going to be what value? Well, now we're going to go to the opposite side in perspective of angle beta. So instead of sine of theta was 4 over 5, sine of beta is going to be opposite, which is 3 over the hypotenuse of 5. So sine of beta will be 3 over 5. Cosine of beta will be what? It will be 4 over 5. Oops, I wrote 5. It'll be 4 over 5. And the tangent of beta will be 3 over 4. Okay, so I want you to notice here that your opposite and your adjacent sides of the triangle flip-flop depending on what angle you are looking from. And your hypotenuse of the triangle is always the same. It's always the angle that is opposite the right angle of your triangle. And something I also want you to notice is that because your opposite and adjacent sides flip-flop whenever you're looking at your triangle from different angles, because that happens, notice that the sine of theta and the cosine of beta are the same value. And notice the opposite's true too. The cosine of theta and the sine of beta are going to be equivalent. And then you can also notice that your tangents are just reciprocals of one another. So that's something to notice. Okay, moving forward, let's solve a practice problem. So let's draw a nice right triangle. Excellent. And let's label. Let's say, what can we do? Let's label this 64. And we'll have this as 5. And this side is x. Let's scroll down a little bit. There we go. Okay, and we want to solve for our unknown value. We want to solve for x. So what can we do? Well, think again, what we have to remember is SOHCAHTOA. This is what we're going to be using whenever we solve all of our right triangle problems. SOHCAHTOA. And in respect to the 64 degrees, what do we have? Well, our unknown is our opposite side, and next to 64 degrees is our adjacent side. So we know that 5 is adjacent, and what we're looking to solve for is our opposite side. So we need to hone in on tangent. Okay? So the tangent of 64 degrees is going to be equal to the opposite x over 5. Now we need to solve for x. We can multiply both sides by 5 and have 5 times the tangent of 64 degrees is equal to x. Now we can pull out our calculator to solve this problem. Let's clear it out. All right. So we're going to do 5 times, it's cleared out. 5 times the tangent of 64 degrees is 10.25. So x is equal to 10.25. Very good. Let's do another practice problem. Okay, let's sketch a triangle. Got our triangle right over here. Very nice. Let's label this as 34 degrees. Let's have this top side be x, and let's have this side be 10. Okay. In here, I'll change colors here so that we don't get confused by the top. Here we'll have, actually let's do it the opposite way. Let's have the hypotenuse be x and this side be 10. So again, we need to be thinking of SOHCAHTOA. And which of our trig functions are we going to use to solve this problem? Well, in respect to the 34 degrees, we have the side right next to it. That's our adjacent side. And we have the side opposite our right angle. We have the hypotenuse. So we should hone in on cosine. We know that cosine of 34 degrees is equal to our adjacent 10. over our hypotenuse x. And now we just need to solve for x. So we can multiply both sides by x to have x times the cosine of 34 degrees is equal to 10. And then we can divide both sides by cosine of 34 degrees to have that x is equal to 10 divided by the cosine of 34 degrees. Now from here, we can simply plug it into our calculator. So let's pull up our calculator, clear it out. We have 10 divided by cosine of 34 degrees. And we get 12.06 as our answer. So that means our hypotenuse has a length of about 12.06. Excellent, excellent. So these past two practice the last two practice problems we just solved, we were using our trigonometric functions to solve for a missing length of our triangle. Now let's use our trigonometric functions to solve for a missing angle. Okay, so let's sketch out another triangle. So here, let's draw a right triangle. So let's say we have a right triangle, and our right triangle looks good. We have some unknown angle theta that we're hoping to solve for. And let's say we have two sides labeled. Here we can label this side 6 and this side 8. And we want to know what angle measure theta is. We want a number for theta. Still, we're going to think to SOHCAHTOA. And what trigonometric function are we going to be using here? Well, in perspective to our theta, we have our opposite side and we have our adjacent side. So we're going to be using tangent. Okay, so we know that the tangent of theta must be equal to what? Well, it's going to be equal to the opposite over the adjacent, so it's going to be equal to 8 over 6. Okay, so this is all fine and dandy, but how can we now find what theta is? Well, all of our trigonometric functions have an inverse, okay? And so what we're going to do is we're going to apply the inverse of our trigonometric function, is denoted by tangent to the -1 power. The inverse tangent is also known or referred to as the arctangent. And what the inverse tangent function does is it peels away the tangent function. And what you do to one side of the equation, you must do to the other. So we're going to apply the inverse tangent function to both our left and right hand side. And like I said, what the inverse tangent function does is it inverses the tangent. So these just cancel out and you're left with theta. Okay, you're left with the angle in question. And so now we just plug this into the calculator. So we pull up our calculator and say, we want, let's clear this out. So 8 divided by 6 is this value, 1.3 repeating. And then we want to apply it to the arctangent function. And here we can see that the arctan of 8 over 6 is 53.13. So 53.13 degrees is the measure of this angle. Excellent, excellent. Let's try another problem to solve for the missing angle measure. Excuse me. So let's draw a right triangle. Let's make this a bigger one. We have our right triangle here. Oh, let's scroll up a little bit. And let's say we are looking for our missing angle, theta. And we know that our hypotenuse is, let's say 25, and this height is 7. And we want to know what theta is. So again, what do we always do? We always think of SOHCAHTOA. And which trigonometric function are we going to be using for this problem? Well, from theta, we have our adjacent side, and we have our hypotenuse. So we're going to be using cosine. So we know that the cosine of theta is going to be equal to 7 over 25. We want to solve for theta, so we're going to apply the arc cosine function, or the inverse cosine function, to both the left and the right hand side. And whenever we apply the inverse cosine function, it's going to peel away the cosine and cancel it out and leave just theta. And then we're going to just plug it into the calculator. So theta, our angle in question, is going to be what? We're going to divide 7 and 25. And then we're going to apply the arc cosine and get 73.7 degrees. Excellent, excellent, excellent. So there's one more thing I want to mention in this little video. We just talked about sine, cosine, and tangent. Those are the 3 trigonometric functions that you're going to use most frequently. However, there's actually 6 trigonometric functions in all. Okay, and the 6 trigonometric functions are as follows. There's sine, cosine, tangent. That's what we spent just talking about. But there's also cosecant, secant, and cotangent. Now, I wrote them in this order because it's important to know the relationship between sine and cosecant, cosine and secant, and tangent and cotangent. These 3 trigonometric functions that I'm telling you about now, they are the reciprocals of the respective trigonometric function above them. In other words, cosecant of theta of some angle is equal to 1 over sine of some angle. And that's true for all of them. Secant is going to be equal to 1 over cosine. And cotangent, let's go up a little bit. And cotangent is going to be equal to 1 over tangent. So let's go up to the very top. I want you to check this out. So whenever we solved for the sine, cosine, and tangent of theta here, what would you do if I asked for the cosecant, for the cosecant, the secant, and the cotangent? What would you do if I asked for these? Well, remember that the cosecant is 1 over sine. It's the reciprocal. So the cosecant of theta is going to be the reciprocal of sine of theta. It's going to be 5 over 4. Okay? The cosecant here, and let me clear out this side right here. Let me clear this out. Get a little bit clean space for us. Write this out so we're not just so overly crowded. Okay, and then let's put that 3 back. Okay, excellent. So the cosecant of theta is going to equal to 5 over 4. And again, that's just because the cosecant is the reciprocal of the sine function. Okay, your secant of theta is going to be the reciprocal of your cosine function. So in this case, it's going to be 5/3. And your cotangent of theta is going to be the reciprocal of your tangent, and in this case it is 3/4. So I just wanted to quickly let you know that there is actually 6 trigonometric functions. To do a full recap super fast, remember the most important thing is SOHCAHTOA, where sine is your opposite over your hypotenuse, cosine is your adjacent over your hypotenuse, and tangents the opposite over your adjacent. Whenever you are solving for a side length, you're going to be looking in perspective to what angle is given, figure out which of the trig functions you're going to use, and then just solve using algebra. At the end, you'll plug in a value into your calculator to get your output. Whenever you are solving for the missing angle, you're going to have to use the inverse of a given trigonometric function. So for this example, we knew that tangent of theta equaled 8/6. We wanted to peel away and take away that tangent function to just leave us the theta. Therefore, we applied the arctangent, and whenever we plugged that into the calculator, we found our missing angle measure. Lastly, I let you know about the relationship of our other 3 trigonometric functions, cosecant, secant, and cotangent, where cosecant is 1/sine of theta, secant's 1/cosine of theta, and cotangent is 1/tangent of theta. I hope you found this video helpful, and I'll see you in the next one.